By factoring and using the principle of zero products, we can solve a variety of quadratic equations. Let's take a look. First, the equation must be in standard form or equal to 0, and since it is, we can now factor the polynomial. The result is a product of factors equal to 0. Factoring this trinomial, we have no greatest common factor other than 1. Our leading coefficient is 1. X squared then breaks into an x in each of the first terms of the binomials. Factors of 6 that add up to 5, both being positive, result in x plus 3, the binomial, times the binomial x plus 2. We can then use the principle of zero products to solve for our solution. One or the other of these factors has to equal 0. Solving for x, here we'll subtract 3 from each side, and solving for x in this possible factor results in x equal -2. The check of our solution of -3 and -2 is as follows. Replacing x with -3 and simplifying by squaring first gives us 9, multiplying of a -15, adding 9 minus 15 plus 6 for our final simplification gives us a true statement showing or verifying that x equal -3 is a solution. Same thing for checking the solution of -2. We replace x with -2 following the order of operations, and we see that we have a true statement. So our solutions to this quadratic equation through factoring are the values -3 and -2. Although there is no constant term, because of the x squared term, the equation is quadratic. So to solve this equation, which is already in standard form or equal to 0, we move on to factoring. First step in factoring is to look for the largest common factor for which x is the value in this equation. The remaining factor is prime. Once x is factored out, we have x plus 7, the remainder. We're done with factoring. Next, we'll use the principle of zero products to solve. Setting each one of the factors equal to 0, we have the following. Nothing needs to be done here. We have one of our solutions, but subtracting 7 from each side leaves us with an x equal -7. To check the solution, the variable is replaced with the value that we found to see if it is true, and x replaced with 0 gives us a true expression, and likewise when we replace x with -7 following the order of operations, squaring, multiplying, and then subtracting, we also have a true expression. So our solutions to this equation are going to be the 0 and -7. Solving quadratic equations using the principle of zero products counts on the equation set equal to 0, making it the first step if it isn't so, as in this problem. So we're going to rewrite it into standard form by adding 16 to both sides of the equation. Now we have the equation in standard form. We will now move on to factoring. There is no common factor other than 1. Because it has 3 terms, we now consider whether it's a perfect square trinomial. First term is a perfect square. Last term is a perfect square of 4 squared. Multiplying the 2 together and doubling is the middle term, so that this does follow the pattern of a perfect square trinomial and factors into the following. We now can use the principle of zero products, taking each of these factors and setting them equal to 0. If a product equals 0, one or both of those factors is equal to 0. This isn't déjà vu, rather each factor is the same, so we get one solution. X is equal to 4. We'll leave the check for you to stop the video and perform. Be careful with an equation like this. Since we need 0 on one side, we first multiply the product on the left and then subtract 9 from each side to put it in standard form. Now we can move forward with factoring because it's equal to 0. First thing, we look to see if there's a common factor. Other than 1, there isn't. Next, is it a perfect square trinomial? 2x squared is not a perfect square. Given 3 terms, then, we look for factoring using guess and check and FOIL. And omitting the details, we have the results of this trinomial factoring into the binomial 2x minus 3 times the quantity x plus 4. These two factors multiply to equal 0, so we now can use the zero product property, setting each factor equal to 0 and solving for x. So here we'll add 3 to both sides and then divide by 2, resulting in x equal 3/2. And for this factor set equal to 0, the possibility that it's causing this equation to be true, we set it equal to 0, subtract 4 from each side, gives us the 2 solutions here that can be checked by replacing these values in the variable for a true answer to the problem.